Thank you. So the two-way table, we use the two-way table to describe the relationship between two categorical variables. When we try to draft up a relationship between two categorical variables, we use the counts or percentage, preferably percentage, because it's more informative. In this section, we're going to learn about the marginal distribution and the conditional distribution. The table here is the example of two categorical variable, sex and the degrees conferred. So basically, when say Mimi, some people ask me like they all numbers, they look like quantitative to me. Well, it's not, right? When you graph this, associate degree, bachelor, master, and doctorate will be on the horizontal axis, right? Column, we have 4 columns, and each column will be the name of your categories. And usually they can convert this into percentage instead of counts like this, right? Okay, so what is the marginal distribution? The marginal distribution of one of the category variable in two-way table of counts is the distribution of values. So let me highlight some important. Marginal distribution is the distribution of values. Basically, it's a fancy way of saying the percentage, right? What you got. What is your percentage in that table? Again, I said this already. I prefer percentage because it's more informative than count. So for example, if I ask you to calculate the marginal distribution for women and men in table 6.1, which is this table right here, what would you do? So what is percentage? What is the percentage of women obtaining the degrees? How will you calculate this? If I ask you to calculate the percentage of women obtaining all the degrees, that'll be, or just percent of the women, just percent of the women. So what's the percent of the women here in this table? Percent of women, just women. I'm just asking, what is the percent of women here? Make it this question simpler. Are you looking at the horizontal row, the row of the columns? Women. Rows, right? It's all the women, all the men add up to 3,905. Okay. So percent of women is going to be 2283 divided by, what was it? 3905. And it gives you some, I didn't have bring my calculator here, give you something. And then percent of men is 1622 divided by 3905, or you can do 1 minus the percent of women. Right, you do something. Can someone tell me what it is? What you got? Okay, thank you. And then yeah, 21.6, huh? Let's see. That is 100%. Okay. So that's the marginal distribution. A lot of times when people do marginal distribution, they do on the sides of the table or below the table. That's why it's called marginal. So I can do so say, because I don't have a space here, maybe I can do on the left hand side. Usually I'm doing the right hand side. So percent of women, percent of men they put on the side. That's where the word marginal come from. Right? They put in the margin. Now, let me ask you something. Is the marginal distribution, look at these 2% here. Does it tell you about the relationship between women and men? Women versus men in terms of degree obtaining? Can you get any conclusion looking at these 2%? No, right? All I know is roughly 58% of women who obtain all the degree and roughly 41.6% of men obtain the degree. That's all. And that's just a sample size, right? I don't know reality, right? That's just sample size. So nothing I can say about when I construct a marginal distribution. So let's try this one, which we're gonna come later. To see there. Okay, so let's try this one. Video game and grades. The popularity of computer, video, online, and virtual reality games has raised concern that they might negatively affect youth. The data in this exercise are based on a recent survey of 14 to 18 years olds in Connecticut high schools. Here's our grade distribution of boys who have played and not played video games. This table does not give you the total of boys who play games and who never play games, so you have to come up with yourself. Okay, so question, how many people does this table describe? How do I find that? How many people does this table describe? Did you guys adding up all the numbers? Is that what you're doing? Oh, okay, good. That's all right. You can tell me like that. So 736 plus 450 plus, I'm going horizontal first, 193 plus 205 plus 144 plus 80. What do you have? Thank you. 1808. I would say people, not players, because roughly half of them have never played. People or boys. Okay. How many of these have played video games? So what do I do? If I answer that, how many people have played video games? What do? I take the first row divided by the total, right? Okay, thank you. So first row divided by total. First row is 736 plus 450 plus 193 divided by 1808. Oh, I don't have to, I'm not looking for percentage. I'm so sorry. I'm just looking for the counts. So how many are there? 1579. Oh, 1379, thank you. 79 people have played video games. Do you guys play video games? Yeah. I think people who play video games, they're really good at like coding and computer stuff. I don't. I wish I can. I'm just not interested. I try to force myself to play, but I'm not interested. I don't know why, but I wish I could have interest to play. I think it somehow it helps your critical thinking too. So playing game sometimes has to be very smart, right? Like strategy. I wish I can have interest in playing, but I don't. But if you do, good for you. Give the marginal distribution of the grades. Give the marginal distribution of the grades. So what that meant is, all you have to do is, so say A's and B's. You do A's and B's, so it'll be what? 736 plus 205 divided by 1808. Same thing here. 450 plus 144 divided by 1808. And same thing here, 193 plus 80 divided by 1808. That's what they call a marginal, because you usually do it on the side. But for me, I'm going to construct a table, and on your exam, I will give you the table. All you have to do is fill in the name, the words and the values. I need A's, so grades, B as A's, C, A, C, D. Need to move it up a little bit. Okay, grades. Oh, grade. A's and B's, P, C, P and D's and F. Percentage. Let's see. A's and B's. What do you have? Those right there. Just let me know what you got. Anyone? 52%. Let's route it into 2 decimal place. 4. So 0.52 something. Right? What is that? So two more number down. B. 4, 6. Thank you. And then C's. Yes. 0.4. Oh, okay. 0.4 and after 4 is 6. So 0.5. Okay, 0.5. And then C's. 32.85. Thank you. And then last one. Maybe what you got? Okay, thank you. 15.1. Very good. Is it 0.099 something? Very good. I'm glad you route up right. This is called route up errors. I'm not talking about it. It's stuff you should already know. So that's the marginal table. All right, and then another question: what percentage of boys represented in the table receive a grade of C or lower? So what do I do? Yeah, all you have to do is add them up together. So 32.85 plus 15.10, 5, 8 plus 1, 9, 7, 47, my handwriting. 47.95%. Receive C or lower. Okay. Do you think the marginal distribution tell you anything about the relationship between two variables, women versus men? I should have said player or non-player. Darn. Player and non-player. What do you say? Yes or no? Put in the chat. Go ahead and put in the chat. Privately. I'm gonna hide the chat here. Okay. Oh, sorry. I'm gonna admit you. Okay. Oh, how come? Oh, it's another chat. I gotta take a look at this chat. Got it. Oh, it's only one people. This chat, is that right? This chat. Oh, there you go. Okay. Yes, yes, no, no. You got done? Because once I give you the answer, you won't be able to receive extra a bonus check mark. Okay. How many no? I got two no's only. Remember what I said earlier? The marginal distribution does not tell you the relationship between two variables, right? Yeah, I can't tell. All I know is roughly 52% receive A's and B's, roughly 33% receive C, and roughly 15% receive D and F. It doesn't say how many percent of non-player versus players receive which, right? So we need conditional distribution, which we're gonna go there soon. So nope, doesn't. Remember that. I will ask it again on the exam on my quiz. Okay, so now conditional distribution. The reason is a conditional because it's based on a condition. I'll tell you what the condition is. Let's say we want to compare the proportion of women. So we go back to the academic by gender, or they say sex. Yeah, you know, gender and sex is different things. Different things. If I say genders, will be wrong. Sex prefer to women and men. What gender prefer to? I forgot. I had this woman study class which I dropped because I was horrible writer. I was received really bad grades, so I didn't want to hurt my GPA, so I dropped. It was here at OU when I was undergrad, and I took differential equation. I was doing fine, but yeah, I don't like that class. It's still like an eye opening, but it's women study, so they talk a lot about racial and how it just too much for me. I guess I don't want to hear the facts. Yeah, it's too much for me. I like fact. I don't have to give my own opinion. I'm not opinionated. All right. If you like it, good for you. Not me. I cannot. If you ask me to write about opinions, I cannot do that. Because for me, I have to have numbers. Have to have something to base on so I can say. It's just like express my feeling. That's personal judgment. That's not accurate. Everybody's different. But people are different. Some people have more colorful thinking than I am. They may do well in that class. All right, so let's say we want to compare proportion of women and men who receive a doctorate / professional degree. Right. Okay, so let's click on the data. Now you won't be able to edit it. You have to make a copy because I can have like 8 people edit at the same time. I think I can click here. Let's go here. Oh, I can go to my Google. There we go. Come on. Oh, there you go. We are chapter 6. All right, degrees. Make a copy for yourself. I'm so sorry. Should have delete that. Don't copy it yet. If you do, delete those. That's from yesterday. It should be like that. Okay, so I want to know the percentage of women only, not men, obtain the doctorate degree. So tell me how you perceive this. You don't have to tell me the answer, the exact answer, but tell me how you perceive this. The percentage of females who have doctorate or professional degree. I know it's not fair because I'm supposed to teach you, but critical thinking, how would you perceive this if you? I guess I just want to know how you approach before I actually teach you how to approach.
I would take 99 because that's 19
Mhm.
divided by the total number.
Total of everything?
Yeah. Or at least between like the doctorate of the men's and the women's combined.
Okay, good. That's one approach. I like to hear that. Anything else? Anyone else have another approach? It doesn't have to be correct. It's new stuff. You're not supposed to have the correct answer in the first try. I want the percentage of women only that have doctorate. So 99 correct, that's your numerator, but the denominator is gonna be the total of all females only. So let's do that. So first we're gonna sum up all the female count. You gotta remember the sum equal sum, right? Equal sum. Make sure you make it capital. And I just want from C2 to C5. Same thing here, equal sum again. C6 to the rest. C6, C9. That's for male. And now the percentage, I want the doctorate, but I'm gonna do everybody. So let's do here. Let's watch me first. Maybe I'll make it bigger for you so you can see. And then I'll leave you a little time to do on your own. Okay, so equal. I want to take this. Say I want to know the percentage of women who obtain associate. Divided by the total of women only. Right? What's that? 2302. 02. It gave me a bunch of decimals. I don't like it. So what I'm gonna do is I'm gonna round it. Oops. Round. Oh, darn. Did I have an equal sign? No. Round. See. And it asks you places, well, 4 decimal places. And then because I want percent, close parenthesis, I want percent, I gotta times it by 100. Right there. Don't check. I just want what? I just want all the way up to female, right? And you gotta do the same thing for male. Go ahead, do that for male. Same command. Just a little bit different numbers. So start. I would suggest you start here. D6. I walk around. Yeah, most of you there, right? On the exam, I will let you use computer. Oh, but you have to face your back to me. And you only allowed to turn on your computer for either Google Sheet or R or the Z table. So what I'm gonna do, I'm lazy, so I'm gonna copy this. Go copy, paste here, and I'll fix it. So instead of 2302, what was that? 1635. 1635. And instead of C2, it's gonna be C6, right? Was it C6? Yeah. There you go. Okay, so this is called conditional margin, conditional distribution. Conditional distribution. Yeah. Conditional distribution. All right, back here. Oh, you know what I forgot? I got to change my share screen. I'll do it next time. I forgot to change to the share screen of the desktop instead of my iPad. Okay, so so we did that. How do we? Okay, so what do you think? How do women and men differ in terms of the degree they project to receive? Maybe here I'll share screen so that when you watch the video you can see. Yes. There you go. Okay, so what do you think? What can you conclude about the difference between men and women about the degree they have? Are they similar? Sort of, they're similar to me. It seemed like bachelor. A lot more women attain associate, but a bit men for doctorate is a bit higher. Yeah, is it because saying that men smarter than women? No, well, mostly because we at this age for doctorate, usually people what 25 or 26. At that age, women usually try to set up their family, right? So it's kids and all that. So that could be one factor. But if you jump to a conclusion that because men are smarter than women, then you forgot about the looking variable. Right? It's more like a social roles thing, which I'm not going to argue with social people because they won't understand. All right. Let me switch back to my screen. Start broadcast. Okay. So we use Google Sheet. See what I do? I put here. If I put something I want to write out. I do put something here. So let me write out something. So we use Google Sheet. And to do this, the percentage of each sex. Oh, so sorry. It's such a bad color. Maybe I'll use black or red. There you go. You can do using calculator if you comfortable with it. Which one you like better, calculator or Google Sheet? Google Sheet. Okay. Maybe on the exam, some people get nervous and they maybe just if the data set is small enough, I'll just use calculator, which is fine. All right. How about the video game? I want you to try the video game, Grace, and I want you to do the same to find the conditional distribution. Okay, so click on that data set and do, oh, you know, before you do that, hang on. I gotta fix it first because maybe there's answer on it. Yes, there is. Come on, how come it doesn't open? How come it doesn't open? You've already opened? Oh, right here. Let me delete that. So you should have something like that. Oh, what do I do?
Task view window, running games, Google Sheets.
Oh, now it have that voice thing. Do you know how to fix it?
Google Sheets, edit, selected.
Oh, a voice to voice over. Where's the delete key?
Selection deleted.
Darn it, I don't want you to talk. How do I mute him? For now,
Okay, volume control.
for now, just mute. All right. Okay, so the sum of yes, first you have to have the sum of yes and sum of no. Yes. The other class, they have to do it themselves. I'll leave it there for you. Let me look at how to fix a voice over. Let's see. This window logo key. And control. Is there a window logo key here? Oh yeah, that's right. Enter. And enter. Okay. I think we save. Yes, we save. We stop. That's why I like to teach in person to actually help you. That's a yes. Yeah, my hand is automatic. I don't. Oh, you should not put the number. Equal, oops. I did something wrong. Equal. No. Now, about one thing about coding that you don't know the whole coding, right? You just kind of you fix it as you go. Right? I didn't know that I had to route it first, but now that I know, I can just start with round. So value is this one divided by 13.1379. I would suggest you put in the number 1379 instead of click on the B cell. Comma 4, because I want 4 decimal places. Close parenthesis times 100 times the star. This is shift 8. Now, when you copy, make sure you hover your mouse over the corner. When it see the little plus, that's when it initiate the copy. You can drag. And again, I'm going to copy this. Change the number. What C was it? C5? 429. All right, take a look at this table. What can you tell me about player versus non-player? Say it louder. Similar. Yeah, sort of. Which one is seem higher? Oh, yeah, that's kind of similar, huh? No, okay, for A's, you can compare grades, types of grades. So A's and B's. It seems like player have a higher, right? Kind of obvious higher. But for C's, I'm C and D's, I'm not sure. I want to compare because it's many factors. So it seems like you play game, you have better, you're doing better at school. You play game, but again, we cannot conclude. There's many other factors as well. Now let's compare with the no, I don't have to compare with the marginal condition distribution. It doesn't tell me anything. So from this conditional table right here, all I see is that it seems player doing better in school. But again, it's not the conclusion. It could be any other factors. After conditional distribution, we're gonna take a little. We're gonna take a attendance and take a little break. So use Google Sheet. Or if you want to use your calculator, you can. But it's gonna take you a little bit longer. What do you conclude? So for me, it seems players have higher grades compared to non-player. But this could due to other factors. But you know, I believe that people who play video game actually they have a better critical thinking. Just the part of the brain like trained to do those kind of thinking. You know. Statistic. Okay, so let's what I'm going to do is I'm going to take the attendance. Okay, so Simpson paradox. Now this part of our chapter is talk about the effect of lurking variable, how bad it's going to affect your data, right? So Simpson paradox is the extreme cases where the lurking variable changes or reverse the relationship of two categorical variable. Right? So for example, on first glance, you see red, but actually when you're dissect into a data, you see blue. So two different answers, right? Even though same data sets. So why is that? Because they're looking variables. And when the extreme like that, they call it Simpson paradox. So the definition is right here. If I was you, I would remember this. Maybe I'll put this on the exam. Or at least remember something about change or reverse relationship between two categorical variables. Okay. At least you can remember. Not the only time I actually check for theoretical part. Okay, so let's take a look at the example. Do medical helicopters save lives? So we compare the percentage of accident victims who die with helicopter evacuation versus road transport. So here, if you take a look at the table, 64 out of 200 people die when using helicopter transportation, and then 260 people die out of 1,100 when using road. So which one have a better chance of surviving? You can do a percentage. Let's see how many die. 64 out of 200. What is that? What's 64 out of 200? So that'd be 32. Yeah, 32%. And what about 260 out of 1,100? So 20, roughly say 24%. Okay, I'll It's not important. I just want some number. So 32% people die using helicopter transportation, and then 24% people die using road transportation. Does it kind of bother you a little bit? To me, a little bit. I would think helicopter would do a better job, right? They're faster. They don't have to wait in traffic. They can get to the hospital faster. Now, why is that? So what I'm a little skeptical. So what I'm going to do is I'm going to dissect a little bit deeper. What happened? Why is it I have this result that I think will be the opposite, right? So what I'm going to do is I'm going to compare the seriousness of the accident. So usually people use helicopter when the accident is what is really serious, right? They need medical attention right away. So they use helicopter, and those serious accidents usually have a high chance of death, right? So that's why if you just take a look at the data in first glance, see it look like people who using helicopter transportation are likely to die, not because of the helicopter, it's because they usually they be more serious accident. So if I take a look at this, serious accident is 48 out of, so for serious accident, I have 48 out of 100, so 48% die. And over here, row is 60% who dies. So now I can see a little more reasonable sense, right? And same thing, survive, 52% survive helicopter, where only 40% survive with road transportation. Where less serious, so less serious accident, same, right? 16% here. And here I have 20% die, right? I'm talking about die. I compare the survive as well. So when I compare with the seriousness, I see different result as I compare with the very first table, the first data set, the general data set. So why is that? So what is the lurking variable here? Yeah, seriousness, right? You didn't take that into account. So seriousness. So seriousness is your, maybe I'll write down here. Seriousness is your lurking variable. Maybe on the exam or quiz, I can, not today. Today, your quiz is gonna be all chapter 9. But maybe for this one, maybe I'll give you a scenario and maybe I ask you what is the lurking variable. You will tell me. What else do I want to know? Okay. One more thing is the lurking variable. In Simpson paradox, Simpson paradox is categorical. Like seriousness is categorical. Categorical variable. Could be plural, it could be singular. So that the association can be misleading when there are lurking variables, right? So maybe I'll put one more. So this implies the association. Well, on the exam, you have to put in context. What kind of association in this context will be what? What is the association here? What the response? What the explanatory? Explanatory is types of transportation, right? The response is your survival rate. So the association can be misleading. Again, on the exam, you need to put in context. I'll remind you, be misleading when there are lurking variables present. So let's take a look at the example. So we can still try writing. Field goal shooting. Here are the data on field goal shooting for two members of University of Michigan 2017 2018 men's basketball team. We have Charles Matthews and Duncan Robinson's. 2-point shot, fighters or 2-point shot. Made and then missed. Same thing with 3-point shot or 3-pointers made and missed by both of the members. What percent of all field goal attempts did Charles Matthews make? So percent Char. See the first name here. Char made. All right, what should I take what divided by what? Somebody do it and then tell me what percentage you got. For Char? I have a different answer.
49.5.
You want like, maybe you divide something. You divide it. How do you
I do, 171 divided by, all four.
oh, okay, I see. You missed the 34. All field goal made.
Oh,
Yeah,
oh,
I got the three shot. Yeah, it's okay. So 171. Thank you both. Plus 34 divided by Char's total was 171 plus 34 plus 136 plus 73 and 49.5%. Of course, you say 0.495, blah blah blah, but I don't care much. On the exam, I'm very generous with number as long as your math is correct. All I care is your math, because later you're gonna use computer to do this when you go to work in a company, right? They're not gonna let you do by hand. But as long as you know what you're doing, you're okay. Duncan made same thing, right? Maybe I use blue. I use blue. The May is 44 plus 78 divided by 44 plus 78 plus 30 plus 125. Hmm? 44, thank you. Okay, 44. So it seemed like at first glance, who do better? Char. It looks like Char doing better right now. Let's see, deeper, let's go deeper. Now we're gonna find the percentage of all 2-point field goals and all 3-point field goals that Char made, and do the same for Duncan. What is this refer to? Is it marginal or conditional? What does it refer to? Marginal or conditional? Remember, what's the difference between marginal and conditional? Conditional a bit more detailed oriented, isn't it? So now I want percentage of all 2-point field goals and so separate all 3-point field goals of Char's, and then do the same for Duncan. Does it sound like conditional to you? Yeah, conditional. Conditional. And the key word here is the key word the key word here is, the key word here is and. So there's an and for the same person, so that means you split, right? Split. That's what happened when we do in conditional distribution, we split, right? Yes, no, right? Well, I guess the key word is really, you have to read it, 2-point, the context really, 2-point field goals, 3-point field goals. Okay, so let's do that with the Google Sheet. Before you do that, let me delete that. Basketball. Now go ahead. Copy that thing. I'll walk around, see how you do. That's our last slide. Yay. I want you to turn it on so you can work your eyes or get the wrong, read the wrong things. Oh no, I don't. It's my bag in the car. I just brought the thing. Darn it. Okay. Oh, yes, on the exam, I'll give you a blank. I'm not gonna give you like that. Oh, you Honey, Netta, finish it. Equal. 414. The 414. Yeah, thank you. 4 times 100. What's the total for Robinson? 277. Thank you. P6. You only copy if you hover, it has a little plus. Okay. If it like this, no, it's not copied. I mean, you highlight it and you delete something or something like that. Okay. So that's the better, right? Am I just oh, did I make a mistake again? Two pointers. They want two. Okay, so this is conditional. This conditional distribution, but it's not refers to the question. The question is what? The question is percent of all 2-point field goals and all 3-point field goals that Charles made. So I want all 2-point of Matthew. So Matthew is what? Matthew 2-point, 2.1, 2. Okay, so here Matthew. Matthew 2-shot. We're gonna get to the safe color, sorry. You don't have to do what I do. This is 3-shot. You don't have to do what I do. Phase. Phase here is Benton. Oh, sorry, I meant to try to make it smaller. Okay. All right, so what's Matthew two shot? What percentage of Matthew 2 shots? You equal what? Equal what plus what? only the May. Don't count. We don't count the miss. So Matthew May is what? This one, right? So this plus what else? May. This as well. And the rest is miss. Okay, so enter equal. So 49.51% for Matthew 2 shots. Matthew 3 shot that he made. Oh, that was 3 shot. I'm so sorry. That was 3 shot. 2 shot. No, let me delete that. Don't do it. I'll do it, and then you do. I'll ask you to do Duncan. Okay. Watch me do Matthew first. So equal. Matthew 2 shot. So 171 divided by the total of divided by 2 shot gonna be 171 plus 136. That plus this, because 2 shot. I only care about 2 shot, right? And made over divided by all made equal. Again, I'm gonna round it. Right. Four times 100. Okay, so that's Matthew 2 shot. I take 171 divided by 171 plus 136. The 2 shot. Matthew 3 shot will be what? 34, right? Divided by what the total of 3 shot? 34 plus 73. Yeah, I'm going to copy this because I'm lazy. I'll just fix some thing here. Let's say D3 divided by D3 plus D5. Maybe you calculated better with this one. Okay, you gotta do for Duncan. I'm doing it too, but you do it on your own. Okay? Duncan 44. I don't have to do 44. Duncan 44. Yes. No, can't see. 2.30. Made 78 divided by 78 plus 3.125. Let me remind you what part A happened. Part A, we have Matthew, M. I'm going to know M is roughly 49.5. And then what else? Duncan B, roughly 44. That's part A. Did you guys get the same answer I do? Very good, very good. So make sure you understand your question. I think that's the more important thing, right? Okay, so What can you tell me? Now, part A, it looks like Matthew doing, yeah, Matthew was last name. So anyway, Charles Matthew had 49, roughly 49%, say 50, Duncan is 44. But when I compare the Matthew 2-shot and Matthew 2-shot versus Duncan 2-shot and Duncan 3-shot, it seems like Matthew had lower percentage, right? So how come overall he do better? That imply what? There is, yeah, the Simpson paradox, right? So, if I ask you something like that, you just say this is see Google Sheet. By the way, if you click on the link in the slide, it'll lead you here. Okay, what I'm doing here, so you can see. This imply there's Simpson paradox. Let's see. Why? Because the comparison that hold for both fields field goal groups. Maybe I don't need ask for fields and goals. Field groups is reversed when we combine into one group. What I meant is part A. Into one group is part A. There's something more. If you look at the count. If you look at the count, Matthew made 771, 2.71, and Miss yeah, you look at the count for Matthew. What happened? The gap is large, right? 171 and 34 and 136 versus 73. Whereas Robinson is a bit more consistent. So notice Charles has a larger gap for 2 point shot compared to Duncan. But again, it could be another variable. But so far, this is what I see. Oh, I'm so sorry. I didn't share. I'm so sorry. I'll post on Moodle. What I said is what I wrote. Really. Okay, when you're done, you can face your back to me, and we're gonna start the quiz. Give me a second, okay? I can All right. You refresh your Moodle page, you should see that. We don't need Google Sheet for this quiz. Mostly critical thinking.